Hey everybody, this is going to be the parts 2 or the second video in this lesson 3 where we're talking about side, 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 and side angle side congruence. Now, this next video deals with proofs primarily. Honors students, you can kind of skip ahead a little bit to start getting to the proof examples. So here, when we're talking about proofs, proofs are basically just using given information about a problem and then also your geometry knowledge, so things that we've learned over the course so far, to prove that something is true or prove that a relationship exists. Proofs, I guess a definition would be just proofs are you're showing organized logic or like your organized thoughts with reasonings to support your logic. So this is very much how people should actually think or critically think. If something's true, you need to provide some support for it or for some reasonings for it. We've kind of gotten out of that, I think, today in the world. So this is why proofs are important. You need to be able to back up with what you're saying with facts, because there's just a lot of conjecture, a lot of people just saying things that aren't true nowadays without supporting it. So that's what proofs are, is basically just making a statement while supporting it. So we are going to use this from your reference sheet to kind of fill out the proofs. So reasonings why sides are congruent. So we've already gone through that in the first video. We could possibly use all three of these. For reasons that angles are congruent, we could use any one of these. And we'll talk about these when we get to the examples. So we're just going to look at 3 example proofs here. We're going to start with the first one. It says, given that JL is congruent to NM, so JL, if you find that, is congruent to NM, and K is the midpoint of JN and LM. So JN is this line here. So if K is the midpoint, it means that J to K is the same as N to K, meaning that those sides here would be congruent. And the same thing with this LM. If K is the midpoint of LM, LM is this line. So if K is the middle, then L to K is congruent to M to K. Now, given that information, we should be able to try to prove that the triangles are congruent. That's what we're trying to do here. So proofs are usually the easiest way to, I guess, to look at them to begin with is to look at this 2-column format. So the 2-column format is statements on the left side. So this is where you're saying things like relationships are true. And then the reasonings on the right-hand side are like why you know that it's true. So the reasoning is always like why you know this statement is true. So keep that in mind as you work through it. So statement 1 says JL is congruent to NM. So if you look back up here, JL is congruent to NM. That's a given statement. So our reasoning would be it's just given to us. Typically in proofs, if they're just copying down given information into your proof, these are just going to be given as your reasonings here. So again, you can mark the congruence. I would recommend marking the congruence on your triangles as you work through the problems, because it should give you an idea of kind of like where you're going after that. So we know that JL is congruent to NM. It also says that K is the midpoint of JN and LM. That is also a given statement up here. So we just write given as the reasoning here. Now, this is where it becomes tricky because you need to be able to interpret what this statement here means. So it says K is the midpoint of JN. So if K is the midpoint, so K is in the middle of JN, that means that the distance from J to K, right here, J to K, is the same as N to K. So we're saying that these two sides are congruent. We know that because it told us K is the midpoint. So this is where definition of a midpoint comes in. Since K is the midpoint, we know that K to J or J to K is the same as N to K. So we can mark those sides congruent like that. Be very similar for statement 4, where they say L to K is congruent to M to K. In statement 4, we know that this is true because they also say that K is the midpoint of LM. So if this is LM, this whole side here, this whole line here, segment, and K is in the middle, that means that L to K is the same as M to K. That's what they're saying in statement 4. So again, that would be your definition of a midpoint. But you should notice that as we mark these, you should notice that we have 3 pairs of congruent sides marked. So that means we know that these triangles are congruent because that satisfies the side-side-side congruence theorem that we looked at in the last video. So this is how this proof would be completed. If you need to rewind this and rewatch them as much as you need to understand the process, that'd be a good idea. We're going to move on to example 2 now. So example 2 says, given information right here, we're trying to prove that JMN, so JMN, we're trying to prove that this triangle on top is congruent to this triangle LNM in the bottom. So it starts off with your given information. Again, most proofs just start off by copying down your given information. So JM is congruent to LN, that's given. So our reasoning is given, and then you can mark the congruence. So these two sides are congruent. JM is congruent to LN. Now, given information also includes that angle JMN. So JMN is this angle right here, is congruent to LNM. So LNM is this angle right here. So those two angles are congruent because they told you, because it's given. Okay, so we have one pair of sides, one pair of angles. If we wanted to try to see that these triangles are congruent by side, angle, side, then we need the other side that's basically would be in between, or the angle here would be this side right here. We need MN to be congruent to itself in both triangles. That's what this statement says here. It says MN is congruent to NM. So it's basically saying that this line in this triangle at the top is congruent to the same side in the triangle at the bottom, which you should be able to see because the triangles are smashed up against each other. They share this side. They share a side. You can say that the sides are congruent to itself by the reflexive property. Reflexive property is used when you say sides are congruent to itself. And then you should notice that we have side, angle, side in the top triangle. And then in the bottom triangle, we have side, angle, side. So because this is side, angle, side congruence, we can say that the triangles JMN is congruent to LNM through side, angle, side congruence. All right, last example here. Again, if you need to rewatch these to kind of figure these out, that'd be a good idea. So the last example here, it says, given that V is the midpoint of WZ and XY, again, in a proof, it just copies down the given information right away. Then we need to start interpreting what this statement means. So it says V is the midpoint of WZ. So WZ is this segment right here, this whole line. If V is the midpoint, that means that W to V is the same as Z to V. That's what they're saying in statement 2. WV is congruent to Z to V. We know that because it told us that V is the midpoint. So the definition of a midpoint, if V is the midpoint, then those two sides are going to be the same. Mark them congruent. Now, this is where it can be a little bit tricky. So it says WVX. So WVX is this angle right here, is congruent to ZVY. So ZVY is ZVY. It's this angle. So they're saying that these two angles across from each other are congruent. We know when two lines intersect and the angles across from each other are always going to be congruent because those are vertical angles. So that would be our reasoning here. We know that these angles are congruent because they're vertical angles. All right, and then in statement 4, it says XV. So X to V is congruent to Y to V. We know that that is true because, again, it says in the original given statement, it says V is the midpoint of XY as well. So XY is this full side here. So if V is the midpoint, that means X to V has to be the same as Y to V. And then you should notice that we kind of have this side, angle, side, side, angle, side congruence. Two pairs of congruent sides, and then the angle in between those sides are congruent. So these triangles are congruent by side, angle, side congruence. So again, if you need to rewatch this, probably be a good idea. The assignment, the proofs on there are fill in the blank. So as you complete lesson 3 assignment, if you have questions, make sure you're watching the videos. As you watch the videos, rewind so you understand every slide, like every slide before you move on. That'd probably be a good idea. Otherwise, lesson 3 assignment will be due for next class. And after next class, or during next class, we will take a look at some of these problems too, so we're all on the same page. All right. Thank you.